Welcome to the first ever Chemistry A tutorial. Today we're going to be talking about dimensional analysis. Today we're going to be working on a few problems, and we're going to start out with the more simple conversions from grams to milligrams and from kilometers to millimeters. So starting with number 36, we want to write down the things that we know. So we know that there is a conversion from grams to milligrams. We know 1 gram is equal to 1,000 milligrams. And knowing that, we can set up our table. We know that 11.978 grams is what we have, and we want to get rid of the units of grams. So in order to do that, we want to place the grams on the bottom and the 1,000 milligrams on top. The reason why we can do that is because we're essentially making a tricky version of the number 1. Since 1,000 milligrams is 1 gram, then 1,000 milligrams over 1 gram is 1. So timesing this 11.978 grams by 1, it is still 11.978. But we're changing it to milligrams, so we're going to times by 1,000. So we can get rid of those units of grams and do the multiplication. That'll leave us with 11,978 milligrams, or 1.1978 times 10 to the third milligrams. Cool. And for the second one, we are looking at 5 kilometers to millimeters. So for this one, it would be easier to take it incrementally. We'll start out with kilometers. We know that there are 1,000 meters in every kilometer. And we know that there are 1,000 millimeters in every meter. So knowing that, we can start our table. We say 5 kilometers, and we want to get rid of those kilometers, so we know that we want to set up something with kilometers on the bottom. So we're going to put the 1 kilometer here and the 1,000 meters on the top. Again, since 1,000 meters is 1 kilometer, we're just making a tricky version of the number 1. So kilometers can cross out. Now we're in the units of meters. So in order to get rid of meters, we need to put meters on bottom. So 1 meter on the bottom, 1,000 millimeters on top. Those meters go away, and here we are left with millimeters, which is what we wanted. So you just do the multiplication across the top, and you are left with 5 million millimeters, or 5.0 times 10 to the 6th millimeters. And there's your answer for number 37. This next part is from number 4 on the fundimensional analysis worksheet. So we'll just go ahead and get to this. Michael Phelps' record time swimming the 100-meter freestyle is 47.51 seconds. How many miles per hour is this equal to? Being that 1 mile is equal to 1.6 kilometers. So this is nice. This already gives us information that we don't have to go hunt down. This is also a very interesting question because we get to see how fast Michael Phelps actually is in water, and something that we're used to seeing. So let's see. He's able to go 100 meters in 47.51 seconds. So this is going to be in meters per second. So let's see. We know that he has 100 meters in 47.51 seconds. Okay, so let's write down some other things that we know that we might need in order to calculate this. We want our final time in hours, and we want our complete unit in miles per hour. So we want this miles, and we want hours. So right now we're in seconds, so we want to be able to say that there are 60 seconds equals 1 minute, and 60 minutes equals 1 hour. Also, we want to be able to remember that there are 1,000 meters in a kilometer. And what else do we have? And I guess the only other thing is this here. There, every 1 mile equals 1.6 kilometers. So now, setting up our table, we're going to start out with meters on top, and we want to get to miles somehow. So I think that the first step would be to use this meters to kilometers. So in order to get rid of meters, we want to put that on the bottom. So we'll times that by 1,000 meters over 1 kilometer. And then from meters, which we can cancel out now, from kilometers, we can now go to miles using this that was given to us. So we want to put the kilometers on bottom and miles on top. And now here's the part that gets a little bit tricky. So we can cross out the kilometers now, but now we have miles, but what unit of time are we in? We're actually in seconds. Since we didn't do anything to this at the beginning, it kind of just carries itself through, and we're left with that on the bottom. So really what we need to do now is look at that and get it into hours. So in order to change that into hours, we can first go to minutes. And to do that, we want to get rid of the seconds. So if the seconds are on the bottom, we want to do seconds on top. So we'll put the 60 seconds here, and we'll put the 1 minute on the bottom, and then finally we can cross those out, and we can say that the 60 minutes is equal to 1 hour. We can get rid of those minutes. And now we can do the multiplication. And what we find is he actually isn't going too fast. Now, when we're doing the multiplication, we multiply across the top, but we also multiply straight across the bottom. And in the end, we divide the top from the bottom. So if we do that, it comes out that he swims 4.736, if you round up, miles per hour. So that actually is pretty fast if you think about it. I think that's, if you've ever been on a treadmill, 4.736, that's, right around 5 miles per hour. That's a pretty good walk, and considering swimming that fast, that's pretty amazing.